Okay, so we're going to be plotting major land formations on a world map, and we're going to observe the plate boundaries that cause these major land formations. So if you choose to do this independently, you are able to print or open your worksheet by clicking this blue link, okay? And then each slide, there's instructions. So here we have our coordinates. And if you don't remember what latitude and longitude are, just look at the directional symbol, the north, south, or east and west to help you. And if you're doing this independently, you're going to use these coordinates and plot using a small V in red, V for volcano. And we go through, there is a slide for each one. So we're going to be plotting volcanoes, mountains. We're going to be plotting mid-ocean ridges, trenches, and island arcs. This is printable. The benefit of this is that you can mark off which coordinates you plot as you go so that you don't get confused or accidentally plot the same one twice. And then this is the world map where we're going to be plotting. Notice the plates, okay? So we have North America and South America, and these dotted lines represent the plate boundaries, okay? So all along this dotted line where my mouse is following is the Pacific plate. Okay, so I have my own hard copy of the coordinates, and the first one I'm going to track is volcanoes. Okay, so over here we already have our colors, and volcanoes will be done in red. So all I'm going to do is click this red dot, and I'm going to hit Control C. I'm just going to copy it. And my first coordinate for volcanoes is 20 degrees north. Okay, so I find north, and so it's going to be somewhere in between 30 and 60. And then the longitude is 110 west. So I need to go towards the middle. Here's west. So here's 90. I'm going to go about here. And then it was 20 degrees north, so I need to be under 30. So I'm guessing about here. Oh, it's going to make me drag the whole dot. Sorry. So it's 110 and about 20. Okay, so somewhere right there. It's not going to be perfect because this isn't gridded. The next coordinate I'm going to do for volcano is 40 degrees south. So we're below the equator, somewhere in here, and 180. So I'm going, 180 is right down the middle, right on this line. So I'm going to grab my dot. I know I'm at exactly 180. So if this is 30, I'm guessing I'm somewhere here. Okay? And I will admit, I'm a little biased on where I'm putting these because the Ring of Fire is called the Pacific Ring of Fire. So it is a chain of volcanoes that outline the Pacific plate. That's why it has its name. Okay, so I'm keeping that in mind when I plot these because, like I said, it's a little difficult because I can't see 40 degrees south. There's not a line for that. So I have to estimate a little bit. The third example will be 30 degrees north, so that makes me happy. 30 degrees north, so somewhere on this line, and 130 east. So here's 120. I'm going to go about here. Okay? 130 east. All right, and then I'm going to do one more for the volcano, and that's going to be 40 degrees north. So I'm going to be above the equator and 140 degrees east. So north and east, 40 degrees north, somewhere here, and 140 east. So I'm guessing it's somewhere right in this area, close to 150. Okay. So so far you guys can see they're kind of outlining this line. This isn't all of the volcanoes in our world. There is a whole lot of volcanoes, a whole lot more than this. These are just clusters. It's to kind of give you the perspective. Like, we didn't plot every single volcano land formation, but the goal is that you guys see the trend, the pattern, that all these red dots outline this area of the Pacific Ocean. That's why they call it the Pacific Ring of Fire, because it's a ring of volcanoes, which are probably a little bit hotter than normal fire. And then other than that, I want you to think about what kind of boundaries are forming these. And as we plot our trenches, you'll start to understand them more. Like, you'll see our oceanic convergent, and you'll see our oceanic continental convergent, which is really what's happening over here. So you have Pacific plate converging with the North American plate in these two areas. And over here, for the Andes Mountains in South America, you have the Nazca plate colliding with the South American plate. Okay? And then Japan, you have, this is where Japan's at. You have major conversion between the Eurasian plate, Filipino plate. There's a small plate here that you can't see, in the Pacific plate. So the next one that we're going to plot are the mountains, which is my brown dot. So I'm going to go ahead and copy that and bring it onto my map. My first coordinate is 30 degrees north and 40 degrees east. So I need to slide this over. 30 degrees north. So we're going over here. 40 degrees east. Can anybody tell me what mountain range they think that I'm plotting right now? Yes, sir. 15 degrees north and 55 degrees east. So we're going to go above zero, not too much, 55 degrees east. So we want to get pretty close, probably about there. Okay, and then we have one more, 30 degrees north, 65 degrees east. Oh. "30 degrees north, 65. So here's 60. Okay, and just based off of what I've plotted here, you guys should be able to tell that the African plate is colliding with the continental plate, the continental Arabian plate. So there is a convergence happening here between the African plate and the Arabian plate. And then there's a convergence happening between the Arabian plate and the Eurasian plate. And that's forming these Himalayan mountain range right here. And then what it looks like is the Arabian plate is basically being sandwiched between the African plate and the Eurasian plate, because this plate is moving toward the Eurasian and the Eurasian is moving down. They're going to squish the Arabian plate. But this right here, these two brown points, are your Himalayan mountain range, and they're formed by the Arabian plate and the Eurasian plate. I need green for my ocean trenches. Let's get some of those plotted. And the first one is 10 degrees north, 95 degrees east. Where would you guys expect to find most of these points on the map? 10 degrees north and east on this side. 0. Here's 95. right there. Good, good. Around the Pacific plate and the water, both of those are really great answers. 5 degrees south, so I'm pretty much there, 100 degrees east. So I really don't feel like I could get any more on that point than I already am. All right, so your third one is 10 degrees south. So a little bit further down than this one, and 110 degrees east. So right about there. Does anybody know what famous trench I'm currently plotting? 10 degrees north, 140 east. You might have heard about it on Octonauts. I believe the Marianas Trench is in this area. It's the deepest trench in the entire world. Mount Everest from the Himalayan mountains could actually fit inside of it. I'm going to plot 4 points for our mid-ocean ridge, and then I'll finish this today, and in the video everything will be updated for you guys in Schoology. Okay, so I need to go copy my blue dot, bring that over, and the mid-ocean ridge, 50 degrees south, 20 degrees east. So 50 degrees south, so somewhere around here, and then 20 degrees east. So we're going all the way over here. Okay? So you guys are going to see there's ocean ridges everywhere. The Mid-Atlantic Ridge is right here along this dotted line, but there are ridges down here as well along the Antarctica plate. The next one is 65 degrees south, so a little bit above the 60 line, and 60 degrees east. Right about there. And then my third one is 45 degrees south, so I need to come back up under 60. And then it's 90 degrees east. So I would say somewhere about here. And 90 degrees east. Okay? So we have a ridge here. Did I plot this one right? 65 south, 60 east. Yeah, okay. And then my last one is going to be 50 degrees south and 135 degrees east. So I'm about already there. I just need to move along this line. Right about there. Okay? So what you guys can see is along this dotted line, there is an ocean ridge here. And as I said before, in between South America and Africa, on the east side of North America, the mid-ocean ridge is right here along this long dotted line. Remember, it goes up past Greenland, which is right here at 60 degrees west and 30 degrees west in between here. And it goes all the way down past the South American plate. And like I said before, I'm going to plot the rest of the points so you'll see a completed map in Schoology where you'll be able to observe all of these different patterns. But the goal was that you see the patterns of mountains when you have land and land, when you have land interacting. You see a pattern of volcanoes that has a big water plate in the center and land plates around the outside to symbolize convergent crust with ocean and land, or ocean and ocean. And with the divergent mid-ocean ridges, you see them along a line in the middle of the ocean, okay, right here in this area. Your trenches and islands also occur where there are those convergent boundaries. And so you'll see all of those clusters. You'll see islands up here. You'll see islands over here by the Filipino plate. That's where Japan would be located. And then around the North American and South American plate for your Caribbean islands. So you're going to see a lot more green dots. You'll see a lot more brown dots. And then these blue dots representing the mid-ocean ridge, you're going to see a whole line of them come down here for the Mid-Atlantic ridge. Okay? So these patterns help us support the theory of plate tectonics and how plate tectonics affect and create these different land formations.